Alright guys, we're going to install our new balance shafts. Just to get that out of the way, I had already installed this new seal. Kind of tricky. I had made a special tool without having to remove this freeze plug and then remove this bracket and get it in there. I basically just used a long extension to pop the old seal out, and I used a bolt and a bushing driver and was able to drive it in. This is the right side. I pre-lubed everything. I did put a little bit of break-in oil or assembly lube on the stub because there is a bushing that's pressed into the block this rides on. For the life of me, I could not find new ones. I'm capable of popping them in and out. I would have had to remove a freeze plug on that side. I probably could have got this one out in without having to do that, but I could not find those bushings. I'm not necessarily worried about it because there's an inner and outer bearing set that this rides in. This more or less is just an idle. Then I did lube the end of this stub because that's what's going to go through that new seal that I pressed in the other day. Kind of like installing a cam. Oh, well, it's in. Up close of that. And basically what it looks like on the other side. Same thing, I'm putting assembly lube on the end of this shaft. The block is considered dry. And there's this weird plastic collar I had to put in there. And I really hope it doesn't slip out of position. Well, I'm spinning it around and I don't hear plastic clunking around. I'll probably spin the motor over and take a look at it. Yeah, it's only letting me move it so far, which makes sense because that tang now is on the bottom, and this isn't. I mean, it's still as far as it's going to go. Basically, we've got our new connecting rods, pistons, wrist pins, retainer clips, bearings. I've got the bearings installed in the connecting rod. Basically, the most important part, and even the manual's telling you, again, a common sense thing, you have to make sure that the bearing is perfectly centered in the connecting rod. These connecting rods don't have any kind of tangs to center the bearing up as the mains did. So what I'm doing is I'm using a small dial caliper, and I'm just resting it. I'm using the outside marks, and I've got it set to 56 thousandths, just because that's kind of the equal gap on both sides. It's pretty close to that. I'm basically just resting it in here at kind of an angle to where that little tack mark, you might be able to see it, is resting on the inside of this bearing, and then the rest of it pretty much lines up with the kind of chamfer, and then you just flip it around, do the same thing. It is locked in position. Kind of flip it around, do the same thing, keep it at an angle, and it should more or less line up with this chamfer line. So now I'm going to go ahead and install the bearings in the caps, and I'm going to just pop them together, and we're going to check our clearance. I'm sure it's fine. Alright guys, same thing like we did with the mains. We're just getting our internal, our rough estimate. So we're looking at 1.88. Just to show you, we're right at 1.88. So same deal. Alright, so right at the 0, we're at 1.88. And since this only measures to the hundredths, let's go ahead and check our first one here. If you look right at, if you count from 0, right is where the needle peaks. It's about 3.5, so 3 thousandths plus 5 10,000ths. So you do 1.880 plus 0.0035. And that gives you the exact internal, well, not exact, but within 5 10,000ths inside diameter. All right, guys, just like the last video, we have a chart here I made. It's measuring the journals or pins for the connecting rods on the crankshaft versus the mains. Pretty self-explanatory. This is the outside diameter of a factory pin. This is what we measured, keeping in mind our instruments are only accurate up to a 5 10,000ths. This is the measured wear. Not even 1,000th on numbers 2 and 3. Moving down here, in this case, the book does actually give us the clearance allowed and what the maximum is, so you don't necessarily have to use the rule of thumb method, the 1,000th per 1 inch of pin diameter. You can just go off the book in this case. These numbers are a little wonky. This is just referencing the position I installed these in. I designated certain connecting rods 1, 2, 3, and 4 based on nothing, just to keep things in order, and these are the positions I installed them onto the crank. For instance, the one I designated as number 2 wound up going in the number 1 position, and etc. It's not that hard to figure out, but these are the measurements of the inside diameter of the bearing shells as they were installed in the connecting rod, only torqued to about 33 foot-pounds. We did not do the final 90-degree sequence using the old bolts as the book recommends. Long story short, I did not necessarily have a vise I was that comfortable with using at the moment, but our numbers are within spec without doing that final 90. And doing that final 90 certainly is going to tighten these numbers up a little bit more. You can see here the maximum allowable clearance is 35 10,000ths. Like I said, this one measured just at 3 thousandths. And again, this is without the final 90. And again, with our limited accuracy, if you'd like to call it that. But nothing real special going on. It's just it's a used crank with new connecting rods and bearings. Little problem I'm running into. It goes in and then kind of stops. The way they had these wrapped up and they had them sitting in here. Well, from traveling, it bounced around and caused these just to roll the edges over just a hair. So you don't want to force the wrist pin in through there. You might, your wrist scratching it up. These are supposed to be able to spin inside both the piston and the connecting rod end. So now basically I need to get in here with a rounded file and just work down those edges ever so slightly. I don't know how well you'll be able to see. As you can see, a big old gash right there. Might be a little more obvious when I try to put the pin in. So you can get in there ever so slightly and work it down. There we go. I mean, that's about as loose as you need it to be. Pin sliding down. Do the same thing I did on the last one. Have to support it from underneath. So it's moving free. That's what you want. Hey guys, I'll try to make this quick and as painless as possible. I just removed all this back out of the engine. Nothing is wrong. Everything went together just fine. I had not done a final torque on the conrods, but something was bothering me only because I had not weighed any of this. I normally weigh every single component independently of each other and match them all up to be the closest as far as static assembled weight, which isn't necessarily mean it's balanced, but I don't have the correct equipment to balance a connecting rod at the moment. Usually you'd have to measure your big end versus your little end and remove material across the top, the sides, or the bottom, depending on what the manufacturer calls for on what part of the connecting rod, remove material to balance the connecting rods to themselves, to balance the pistons to themselves. Normally you'd weigh your rings individually, you'd weigh everything individually and then match everything together. In this case, we were dealing with a used crank, so again, I wanted to match the assembled big end with the right bearing because as you saw, there was a slight deviation in clearance, so I wanted to match the set to the right pin on the crank, which is fine. But what I wanted to do after that was match the right piston to the connecting rod to get the right weight, at least to get it as close as possible without having to remove any material off of anything. Because these days with OE supplied components, everything's within a few grams of each other, if not a gram. This is another case in point. This motor was very close. So what we did is I had disassembled all this, sprayed all the lube off of everything. I had engine oil and assembly lube on everything. So what I did, just for peace of mind, and I'm kind of glad I did this, I measured the pistons by themselves, the wrist pins by themselves, and the connecting rod by themselves. Now the connecting rods did have the bearing shells and new bolts, which is what's going to be going together. So that's what these weights came out to be. For whatever reason, I did have a wrist pin that just measured a little heavier than the other ones, so it is what it is. Sometimes you run into that. But as you can see, ignoring these arrows, these are the weights of everything individually as it was installed in the motor. So that puts number 1 at 1048, 2 at 1044, etc., etc. This is the combined weight. This is the combined, the connecting rod, the piston, the wrist pin, the circlip, everything assembled, plugged in the hole, tightened down to the crank. That's what the full weight was in grams. We're measuring this in grams. So as you can see, this was how it was when I just threw it all together. This is a flat plane style crank. This is not a cross plane crank, which means you have 2 pins that are opposing 2 additional pins at 180 degrees. You don't have a pin every 90 degrees. You have 2 pins every 180 degrees. So ideally, dealing with basic math and physics, you want number 1 and 4, the sum of 1 and 4, you want to equal the sum of 2 and 3, because you have one big chunk in the center and then 2 opposing chunks on the outside. So you would want the sum of those two numbers to be even. You don't necessarily want the like this is very close. 3 and 4. 3 and 4 are opposing each other. You think that's fine. But 3 and 2 are connected on the same, they're on the same parallel. So again, it's, I'm sure you all already understand this. You want that your opposing mass to equal, you want opposing masses to equal each other, basically. It's as simple as that. You can get way more technical with that. I'm not by any means claiming that's, you know, in stone. I mean, but we're also dealing with a motor that's has an internally balanced crank, a harmonic balancer, and twin rotating balance shafts. So there's also that. As you can see, these two outside numbers wound up being 2,097 grams, and these, the sum of the number 2 and number 3 was 2092. So as far as our basic counter rotating assemblies, we were 5 grams off. So all I did, basic math, we had a connecting rod that came in a little light. I don't know why. You know, obviously these usually would be having some material taken off of them, because you can't add weight. You can remove weight. Well, actually you could technically add weight, but you go off your lightest one and you match the other ones. You make all the other ones weigh that much, depending on where you're removing material, where the heaviest part is, how much of the little end, big end you got to take apart. Anyway, all we did is some basic math. We swapped out the piston and wrist pin that was originally installed on number 1. We just swapped it out with number 2. That removes 2 grams from number 1 and adds 2 grams to number 2, which puts these numbers at 1046. So the sum of 1 and 4, which obviously changed now, we're at 2095, and then the sum of 2 and 3, we're at 1094. So now, by doing nothing but just matching up your basic, basic numbers, we're only 1 gram difference. But this is probably one of the most important parts, aside from your bearing clearances, is this is free. This is just matching the correct piston to the correct rod. That costs nothing. All right, guys, I've already got number 2 and 3 installed in 33 foot-pounds down. I haven't done the 90 degrees yet. I'm just putting a little bit of assembly lube on the bottom of the main cap, not the main cap, the rod cap, on number 1. So we've got everything reassembled. I've been triple checking, double checking everything. I'm ready to go ahead and lube this one up again. I'll make sure you get nice fresh engine oil over all the rings and the lands, especially on the oiler. Do a little squirt on the side of the cylinder wall. Fresh coat. You can't really see because I had these marked. I can still just barely see. You want to install your compression rings 120 degrees offset from each other. So there's also a little arrow that tells you the direction to install these on, if you didn't know already from removing them in the first time. What I'm doing is I'm moving the oiler ring towards me, as in the position I'm installing it, so I can see the gap on the oiler ring as it's compressing, because my tool allows for that. So I'm just going to very slightly lower this into the bore. I'm going to rest it on the oiler ring, and then that allows me to spin my rings. My secondary ring, I'm going to put at my 0 mark and push the bottom of it this way so the openings are out towards the front. I'll put the top ring on my 120 degree mark and push it that way, so as it compresses they stay on the mark as it's compressing towards the mark. Same on number 2. And I can see my oil ring gap is offset. It's not lined up with a compression ring. I keep steady pressure on this. Nice and slow, steady squeeze, keeping an eye on that oil ring. Making sure everything's compressing, giving it a little jiggle. Making sure there's no binding. It feels right. Now we're at it's fully closed and fully seated. I'm just going to press down ever so slightly with my thumb as I let off the pressure slightly on this, and they slide right in. So again, I'm going to turn the gap on the oil ring towards me. I'm going to go ahead and lower this down into the bore. Oh. Nice fresh coat of oil. Drop her down in here ever so slightly. Go ahead and move my rings. Number 1 at 120, secondary at 0. Just barely see my mark. That's about it. Same deal. Oops. So just very, very slightly. Keeping an eye on that oil ring. The compression rings will take care of themselves. You'll know right away if something's bound up. And basically when you're as tight as you can get, same thing. You do want to make sure the pistons line back up evenly with the valve reliefs. A little bit of pressure on the dead center as you let off slightly on the pressure of your installation tool, and it slides right down in. Just going to gently press this in, take my index and my middle finger so I can just reach the bottom of the connecting rod. Slowly massage the top part of the piston as I'm pushing in. Kind of reach around and grab it. Slightly pull it towards the pin ever so slightly. And there we go. Make contact. Check our bearing gap. Not so much the bearing gap, but the center of the bearing on the pin and in the rod. Do that on this one as well. We're good. All right. Number 1 I had marked earlier. Again, making sure everything's going the right way. You'll know very quickly when you go to install this. Obviously, double check, make sure your bearing's still where it needs to be. Go ahead and massage it together. Throw half a thread on a bolt because these need to be oiled. She's getting there, guys, and I'm very glad I went back and weighed everything and swapped out 2 of those pistons and wrist pins. But, all right, guys.